Hello and welcome. This is Additional Mathematics Form 5 Kssm textbook question, Chapter 2, Formative Exercise 2.2. My name is Terry. So if you enjoy this video, please like, and also if you want to receive more notification when we upload a new video, please click subscribe. And also if you have any feedback, please comment so that we can improve our video presentation. Alright, let's go straight to this. Okay, so if you want to find the derivative means differentiate this function, you can write as in the form of d dx, or you can just let y be this. Now one way of writing is, of course, you have to copy the question d dx of this function. And remember, when you differentiate, there are actually four main differentiation technique. The simple four, the basic four I would like to call it. The first one is y equals to k. When you differentiate constant, you get 0. Second one is the linear form. When you differentiate kx, dy dx will be just k. Alright. Number 3, when you have y equals axn, the general form. So when you differentiate dy dx, you get an xn minus 1. Number 4, if y equals a over x power n, dy dx, you put a negative in front, copy a times n, copy x, increase the power by 1. So when I differentiate 9x squared, this is using formula number 3. We take 9 times 2, I get 18. I copy x, reduce the power by 1. Now, when you have negative 3 over x squared, here I'm using formula number 4. So we put a negative in front. Automatically, this is positive. 3 times 2 is 6. I copy x, and I increase the power by 1. I get x cubed. Now, if you do not want to write this, what you can do is we can just let y equals, right? So you don't have to write d dx, don't have to copy the question. Then we can just write this as dy dx. Okay, again, let's identify. This one we have to use formula number 4, put a negative in front. 6 times 3 is 18. You copy x, increase the power by 4. When you differentiate negative 1 over x, remember, when you have the x is below, you got to put a negative in front. Since there's another negative here, automatically becomes positive. 1 times 1, this is 1 here, 1 times 1 is 1, copy x, increase the power by 2. When you differentiate 8 is a constant, you will get 0. Okay, next one, again I'm going to let y be this, but c, dy dx will be differentiate 5x, you get 5. Now for 4x, square root x, we write x power half, so we take 4 times half, which is just 2, copy x, reduce the power by 1, half minus 1 is negative half. When you differentiate negative 7, you're differentiating constant, so it's actually 0. So your final answer is 5 plus 2 over square root x. Remember, power half means square root, power negative means 1 over. Maybe I write down here, power half is square root, power negative is 1 over, power negative half simply means 1 over square root x. Okay, part D, again, maybe in this case, before I differentiate, I would write in the power of as power half, square root x as power half, and cube root as power 1 over 3. Maybe it's easier that way, so you can see it. So the first part, when I differentiate this, I put a negative in front. 10 times half is 5. I copy x, I increase the power by 1. Half plus 1 is 3 over 2. The second one, I put a negative in front. 3 times half is 1. Copy x, increase the power by 1. 4 over 3. There you go. That's your answer for question number 1. Okay, moving on to question, well, I have the second part. Question number 1, part E, F, G, and H. So now, if you have a bracket square, actually, some of you probably have learned about the composite function, the composite function method. That is, you can bring the power down, copy the bracket, reduce the power by 1, and differentiate inside the bracket. Well, you can do that, but for the early part, the preliminary part, well, I would say it's better to just expand it. Yeah, it's not to say it's easier, it's about the same. So when you expand, because this is power 2, we can expand this x power 2 power 2. I'm going to show you the slow method, the a plus b squared, which is what, a squared plus 2ab plus b squared. Now my a is x squared, my b is negative 3 over x, and my b squared is negative 3 over x bracket square. Okay, so this is part E. I'm going to write vertically downwards, yeah, because of lack of space. So this is x power 4 minus 6x plus 9 over x squared. Now take note, I haven't differentiated anything yet. So what I've done is I've just expanded and rewrite in the basic form, general form, the y equals k, y equals ax, kx, y equals to axn, and y equals a over x power n. So when you differentiate 4 x power 4, you get 4x cubed, right? This is axn. This one, the negative 6x, is a linear form. So when you differentiate negative 6x, you get negative 6. And when I differentiate 9 over x squared, you put a negative in front. 9 times 2 is 18. Copy x, increase the power by 1, 3. Alright, so that is part E. So for part F, it's actually better if you were to split them into 2. Now when I say split, means I write 8x squared, x power half, and this is x power half. So when you divide them, this is x power 3 over 2, this is x power half. 2 minus half is 3 over 2. This is x power 1, 1 minus half is just half. So when I differentiate 8 times 3 is 24, 24 divided by 2 is 12, copy x, reduce the power by 1. The second one, bring the power down half, copy x, half minus 1 is negative half. Now normally we don't leave our answer as power half or negative half, so what we do is we bring this down, change it to root x. Okay. Now it's not wrong if you do change it, but it's just better. Yeah, it's easier later on when you substitute the value inside x. Yeah, it's easier to see when it's written in the form of root x. Okay, moving on to G. Well, this is actually easier, so I'm just going to let this be y, right? And I'm going to just write dy dx. This is easier because you can just differentiate directly. This is formula number 4, negative in front. Now, but the thing is there's a 3 here, so you want to think 4 over 9 times 3 here. Copy x, increase the power by 1. Then when you differentiate pi x, you're just getting pi. Now remember, pi is just a constant. Yeah, when you differentiate pi x, you get pi. Differentiate 6, you get 0 because 6 is a constant. Your answer, can we cancel? 3 and 9, 4 over 3 x power 4 minus pi. Okay, part H. Maybe it's better you multiply inside. So I'm going to write this as power half first. 2 minus x. So when I multiply inside, I get 2x power half. Power half times power 1 is power 3 over 2. So when I differentiate, I take half times 2, which is 1. I copy x, I reduce the power by 1, negative half. Second one, when I differentiate, I bring the power down. I copy x, 3 over 2 minus 1 is 1 over 2. So this is 1 over square root x and 3 over 2 root x. Okay, I think this is not that difficult, right? Yep. So let's move on to question number 2. Here we have to differentiate and substitute x with 8. So the first time you differentiate, we write f prime x. We take 3 times 2 over 3, which is what? Okay, maybe I write this down for you, easier for you to understand. This is 2 over 3 minus 1, and this is 6 times negative 1 over 3. So when you take negative 1 over 3 minus 1, yeah, this will give us negative 4 over 3. Yeah? But okay, let me do one by one. We cancel the first one, 2x. 2 over 3 minus 1 is negative 1 over 3. 6 divided by 3 is 2. This is x power negative 4 over 3. Now we probably want to bring this back down so it's easier to see. I think maybe I'll just write this as x power 1 over 3. You can write this as cube root though. Alright, and this is 2 over x power 4 over 3. So the next step is to put 8 inside. Now we know if I put 8, we can calculate this, right? 8 inside, 8 power 1 over 3 we can calculate. This is 8 power 4 over 3. So cube root of 8 is 2, so 2 over 2. Cube root of 8 is 2, 2 power 4 is 16, so it's 1 minus 1 over 8. Answer is 7 over 8. Alright, so moving on, let's look at question number 3. So here you're given ft in terms of t. So we can first, number 1, simplify this. I'm going to bring this up. This is 6t power 3 divide t power 1 over 3. So when you divide the number, we minus the power. So this is 3 minus 1 over 3. Well, we can write this as 3 times 3 is 9. 9 minus 1 is 8. 8 over 3. Part B, you're supposed to find f prime t. So when you differentiate 6 times 8 over 3 t, 8 over 3 if you minus 1. So I'm doing very slowly here for you. Cancel, cancel, you get 16. This is t power 5 over 3. Okay, C, find the value of f prime 1 over 8. So when we substitute 1 over 8 inside, right? So 1 over 8 is simply, we can think of it as 1 over 2 power 3. There's a 5 over 3 here. We can cancel them. You're left with 2 power 5. 2 power 5 is 32. When you simplify further, you get 1 over 2. Question number 4. So here you're given s is 3t squared plus 5t minus 7. Find ds dt. So when you differentiate ds dt, differentiate 3t squared, you get 6t. Differentiate 5t, you get 5. Differentiate 7, you get 0. And find a range of values of t such that ds dt is negative. So if your ds dt is less than 0, 6t is less than negative 5, t is less than negative 5 over 6. Alright? Okay, question number 5. So now, given dy dx at 0.14 is 7, find the value of a and b. So here, when you have two unknown in your equation, we have to form two equations, right? So the first equation, we can just sub 1 and 4. That means my y is 4 when my x is 1. So a plus b is now 1. Yeah? Okay, this is a bit ugly. Let me fix this. A plus b is now 1, so I'll leave it first. The second step is we're going to differentiate dy dx. Differentiate 3a, ax power 3 is 3ax squared. Differentiate bx squared, I get 2bx. Differentiate 3, I get 0. Now we sub in x with 1. Can you see your x coordinate is 1 when the dy dx or the gradient is 7. So we can write 7 equals 3a. 1 I sub inside is still 1. So actually you don't have to write the 1 here. So this will be 2b. Okay, so 3a plus 2b equals 7. Equation 2. Now, how you want to solve this simultaneous equation is up to you. You can use elimination or you can use substitution. I personally like elimination. I'll just take equation 1 times 2. So 2a plus 2b is now 2. I call this equation 3. We'll just minus equation 2 minus equation 3. And I'll get my a equals to 5. When I sub inside equation number 1, 5 plus b is 1. B is negative 4. Okay, let's move on to question number 6. You're supposed to find the coordinate of a point in a curve such that your dy dx is 3. So step 1, we differentiate. When I differentiate x power 3, I get 3x squared. Hope you're okay with your technical differentiation. Right, differentiate negative 3x squared. 3 times 2, 6x. Differentiate 6x, you get 6. Differentiate 2, you get 0. Now my dy dx is 3. So just sub inside here. Right, we can rearrange. I'll bring this over. So 3x squared minus 6x plus 3. 6 minus 3 is 3. Let it be 0. Just divide everybody by 3. Make the number smaller. So what we can do is we can factorize this. Now notice that this is in the form of a squared plus 2ab plus b squared. We can actually factorize to a plus b squared. Yeah, don't have to use double bracket factorization. So x is now 1. When you find coordinate, you have to find x and y. I've got my x, I need to find my y. So I sub 1 inside my y here, and I will get 6. Yeah, so your coordinate is just 1, 6. Okay, so I would say some questions are quite easy, some questions are a little bit difficult, a little bit. So I would guess like the past few questions a little bit easier. Right, so this one involving finding h prime x, yeah, in terms of k. So again, we differentiate as usual, but although I have a k, remember k is a constant, it's not affecting your differentiation. When you differentiate, you bring the 3 down, copy k, copy x, reduce the power by 1, 2, differentiate 4x squared, 4 times 2 is 8, copy x, reduce the power by 1, 1, differentiate negative 5x, I get negative 5. Now that is only part A. Part B, I'm supposed to find the value of k given that h prime 1 equals to 8. h prime 1 means we substitute 1 inside my x, and the result is just 8. So 3k minus 8 minus 5 minus 13 equals to 8. 13, when I bring over 13 plus 8 is 21. 21 divided by 3, I get 7. Alright, let's move on to question number 8. Okay, this one involves composite function. So I've actually shown you the basic 4. So there are 2 additional formulas for composite function that you need to know. The first one, and like I say, the way I teach may be a little bit different from what you learn in school, because I find, I will show you some shortcut, the easier way. So let's start with this one first. Where the bracket is on top, that means kfx with the bracket power n. You bring the power down, you copy the bracket, you want to reduce the power by 1, and you differentiate inside. Okay, so this part A and B involving this formula, formula for composite function. So when I differentiate, you want to bring the power down. Okay, maybe as a beginner I'll show you like 3 over 4 times 4. Copy the bracket, reduce the power by 1, 3. Now when I differentiate x over 6 or 1 over 6x, I'm actually getting 1 over 6. And we can actually cancel these two. Okay, I can cancel 3 and 6, left with 2. So I still have a half outside. So I'll write the half here, x over 6 minus 1 power 3. Okay, for b dy dx, let's take 6 times 1 over 12. Maybe I write 6 over 12. 10x minus 3, reduce the power by 1, 5, differentiate 10x, I get 10, right? Now this will be half, we can cancel half, right? This is actually half, right? And 10 divided by half is just 10 times half, which is 5, with a 10x minus 3 power 5. So in the event that the bracket is above, yes, we use this formula. Now what if the bracket is below? All right, again I like to use the one similar to formula number 4, the reciprocal form. That is, when I differentiate, I put the negative in front, k times n, copy fx, instead of reducing the power, we increase the power by 1, and we differentiate inside. So this is much easier, because I know a lot of teachers with school will tell you, okay, bring the power up, 2 minus 5x power negative 1. So when I differentiate, I bring negative times 8, I copy the bracket, I reduce the power by 1, and I differentiate inside. So I still have to simplify this. Negative 8 times negative 5 is 40, and 2 minus 5x squared. I know some people say slow and steady wins the race. That is BS, I would say. So so this is the fast way. Let me show you the fast way. Okay, method 2. Okay, now method 2, fast and furious, wins the race. Okay, so you put a negative in front. 8 times 1 is just 8. You copy the bracket. Instead of reducing the power, we increase the power by 1. So this will be 2, right? Based on this, I look at the question here, and I differentiate inside the bracket. I have a negative 5 there, so it's 42 minus 5x squared. Okay, so this method is actually better, right? Because you don't have to bring the power up and then differentiate and bring it back down, so we can just do it one shot. All right, so we still have a few more on this. All right, question number D. Now D is actually using this formula here. Actually I like to call this formula number 5, this formula number 6. Okay, right? So the 5 is the fifth one is the composite function with the bracket on top. The sixth one is the composite function with the bracket below. So let's look at D. I'm going to use formula number 5, right? So when I differentiate, I'm going to bring the power down. I copy x minus 1 over x, reduce the power by 1, 2, and differentiate inside. Now when I differentiate inside, I get 1 minus becomes a plus. I remember this one, I'm using the a over x power n plus 1 over x squared. Okay, now you might be saying or might be thinking, how come just now we came across a question like this, right? But we actually expand it. Now you can actually use the same formula as this. You can use the composite function method, right? But for power 2, some people may find it's easier to just expand it, because you can expand it, right? That means you can just expand 2 plus 1 over x squared, and then you differentiate 1 by 1. Now you can also, this is your dy dx, you can also bring the power down, copy x, reduce the power by 1, differentiate inside the bracket. and when you simplify this, you are getting the same thing as well. But again, the choice is yours. It's up to you whether you want to use expanding, yeah, or the composite function. But in this case, I cannot expand because this is power 3. You haven't learned how to use binomial expansion yet, yeah, not in SPM syllabus. So yeah, we'll just have to leave it in this form. Okay, if you want me to make it look better, I guess that's all I can do. There's nothing much you can simplify, okay, because you cannot expand this bracket over here. You can't expand the bracket over here. All right, so I think we'll just leave it like this. Okay, it's good enough. Now, however, I want to say this. There's a disclaimer about this function here. All right, there's a disclaimer about this function. Like mentioned, you can use a fast way, but this function and this method of differentiating, that is, we put a negative in front, copy k times n, copy fx, increase the power by 1 and differentiate inside. This method is good, yeah, okay, this method is good, okay, for any function actually, but some people may find it's better to bring it up. Yeah, some people may find it's better to bring it up. You can do that, okay, because I know, especially your n. Okay, let me give you one example. Okay, let's say you have, okay, 2x minus 1 power, let's say 5/3. Okay, I think I need to give you, okay, I tell you what, I don't have to give you this. Yeah, I think it's not necessary for me to show you this lah. Yeah, okay, I tell you what, I'll just show you this straight away. Yeah, you can bring it up again, right? So I think I don't have to show you that lah. Too many things is complicating the whole process. So I'll just put a negative in front. See, 1 times 1/3 is 1/3, but I'm going to put a 1/3 here. Copy the bracket. I increase the power by 1, 4/3. And when I differentiate inside the bracket, what I have here? I have a negative 9. So when I cancel it, I get 3 minus 9x power 4/3, right? So if you want to bring it up, differentiate, bring it back down, also can. Up to you, right? Up to you. All right, so let's look at f. This is D, E, F. Okay, now f is a bit interesting because you have a square root, and on top of that you have like a quadratic expression inside. So when I differentiate, I'm going to bring the power down, I copy the bracket, I reduce the power by 1, half minus 1 is negative half. So differentiate is 2x plus 6. Now notice that 2x plus 6 you can actually divide by 2. That is, I can cancel this, yeah. You can write one more step, but that is, you factorize the 2, take out x plus 3, keep the 2, the half here, the power negative half, you bring it back down, and when I simplify it, this is what I'll be getting. Okay, I hope you're okay with this. So let's move on. Question number 9. So y equals 24/3x minus 5 power 2. Find the value of dx when x is 2. Okay, again, I'm going to use the fast way. Put a negative in front. 24 times 2, 48. I'm going to copy the bracket, 3x minus 5. Increase the power by 1, 3. When I differentiate inside the bracket, I have a 3 here. This is negative 144. 48 times 3 is 144. And this is 3x minus 5 power 3. Now I need to sub x with 2, so negative 144, 3 times 2 minus 5 power 3. So it's negative 144 over 1, which is just negative 144. Alright, so that is not that hard, right? Okay, number 9 done. Number 10. So we're going to find the value of constant, given that the result of differentiating this is this. So okay, let's just differentiate as usual. Negative in front, 1 times 3 is 3. Copy the bracket, increase the power by 1, differentiate inside, get 3. I compare with negative a, 3x minus 2 power b. So you notice if you compare this negative 9 with the 3x minus 2 power 4, this negative a with 3x minus 2 power b. So we can just compare directly, as in I can compare 9 with a. I can compare 4 with b. So by comparison, I can say A is 9, B is 4. All right, okay, not too difficult, right? All right, okay, let's do something more challenging. This is the one that's a bit more challenging, the product rule, right? And now this may be a bit long. I may have to squeeze everything inside. All right, product rule works like this: y equals to uv. So when I differentiate dy dx, I copy u, differentiate v, differentiate u, copy v. Now there's another version. Sometimes they say duv prime plus vu prime. Now I personally find the uv prime, u prime v is better because we arrange it in order straight away. It's easier for you to factorize. Okay, let's look at the first one. This is just your y, this is your u, this is your v. Okay, part A, dy dx. So I copy my u for x, differentiate my v. Now remember, this involves composite function. So we're going to bring the 5 down, copy the bracket, reduce the power by 1, 4, differentiate inside 2. Then you differentiate your u, differentiate 4x, you get 4, and you copy 2x minus 1 power 5. I think the differentiation part is not that hard. It's just that the factorization, some students may find this is a bit difficult. Now, I have a standard way and a slow way. If you want, the standard way is, I think it's better if you multiply the number together. 4 times 5 times 2, that will be 40x. I think when you write in this order, it's easier for you to see. Yeah. So number one, we can take out common factor. My common factor, if you notice, the between 2x minus 1 power 4 and power 5, we always take out the smaller power being 2x minus 1 power 4. Okay, and I put a bracket and a plus sign in between. The second one, I can take out between 40 and 4. We can take out 4. Always take out the smaller one. So once you've taken out 4, now remember, factorization is like dividing. So when you take 40 divided by 4, you're left with 10, right? And I still have an x there, right? I still have an x over here. Can you see that? Okay, I need to remove this. Now, for the second term, I've taken out 4, I've taken out 2x minus 1 power 4, left with 2x minus 1 power 1. Now, I don't have to put a bracket power 1, but if you want, I can just put a bracket power 1 here, right? It's the same thing. Whether you write the bracket or not, it doesn't matter because it's power 1, okay? Let me just remove it. So now you're left with 4, 2x minus 1 power 4, and 12x minus 1. There you go. Yeah? I hope this is not too difficult. Okay, B, let me write down the question. X power 4, 3x plus 1 power 7. Okay, so this is my u, this is my v. dy dx. Okay, copy your u, differentiate your v, bring the 7 down, copy 3x plus 1, reduce the power by 1, 6, differentiate inside, differentiate 3x, I get 3, differentiate 1, you get 0, so you don't have to write. And when you differentiate my u, I get 4x power 3, and I copy 3x plus 1, actually plus 1 here, and this is power 7. Okay, from here, I need to take out common factor. Okay, again, I like to multiply first. 7 times 3 is 21, x power 4, 3x plus 1 power 6, 4x power 3, 3x plus 1 power 7. So I have a common factor, 2 common factor in fact, right? So always take out, let's say, bracket power 6 power 7. What can we take out? We take out the smaller one, power 6. Right, there's a plus sign between. Alright, then x power 3 and x power 4, you can take out power 3, smaller one. Now the third one, 21 and 7, there's nothing you can do. 21 and 7, you don't have a common factor, so we cannot take out. So I'm left with what? 21 here, right? X power 4 divided x power 3, x power 1. The 4x power 3, I've taken out x power 3, I'm left with 4. But the 3x plus 1 is still there because it's power 7. When you take out power 6, you're left with power 1. So this will give us x power 3, 3x plus 1, power 6. And this will be 21x plus 12x plus 4. When you simplify further, you should get 33x plus 4. Okay, I hope this is not too difficult, right? Okay, C. This is your u, this is your v, x plus 3 power half. This is your u, this is your v. Okay, so when I differentiate, I copy u, differentiate v, half, bring the power down, copy the bracket, reduce the power by 1, differentiate inside. Then when I differentiate x, I get 1, I copy x plus 3 power half. Okay, now this may look a little bit confusing, so I'm just going to copy and write in this form. Okay, before I factorize, right, actually I just want to tell you that if you have x power negative half and x power half, we can always take out the smaller one. Smaller one means power negative half. So when you take out negative half here, you're left with 1. Now x power half, when you divide with x power negative half, is actually x power half plus half, which essentially is x power 1. Right, so likewise, we can take out this x power half. Yeah. Oh, by the way, what happened if you have, okay, let me take out x power half here first, negative half first. All right, I'm going to put a plus sign here, I'm going to put here. Okay, we know we have to take out x power negative half. The second thing is, if I have half x plus 1, what can we take out actually? Actually, you can take out half. So when you take out half, this is x. Now 1 divided by half is the same as 1 times 2. So if you don't believe me, half x plus 1, you can actually say, oh, I times top and bottom by 2, so it's x plus 2 over 2. Or half of x plus 2. Isn't it the same thing? Yes? Okay, now the thing is, if you have a half here and I take out the half here, this will just be 1x. Right? But the second one, you got to be careful because I've taken out half, it has to be 2. And this power half, if I taken out power negative half, I'm left with power 1. So this will be 1 over 2 with the square root. Remember, power negative half is square root. And this will be just x plus 2, x plus 6. When you add up, this will be 3x plus 6 over 2 square root x plus 3. If you want, you can factorize one more step. Take out 3, x plus 2, 2 over root x plus 3. Okay, I want to show you another way. Because some students find this is a bit confusing, especially factorizing power negative half. So maybe what we can do is, okay, I just draw arrow here, method 2. Some students may prefer to keep this as, okay, let me see, I can just change this to x over 2 square root x plus 3. This is square root x plus 3. Some students may find this is easier. That is right in the form of fraction. Now we know if you want to combine a fraction, you need to have the same denominator. So root x plus 3 actually has a denominator of 1. So you just have to multiply top and bottom with this, right? So this will give us x plus 2 of x plus 3 over 2 root x plus 3. Now you notice this is the same thing now. Can I just cut short? X plus 2x. This is 3x plus 6 over 2 root x plus 3. And it's just the same as 3x plus 2, 2 root x plus 3. It's not that you always have to factorize using the first method. You can even use the second one. Yeah, if you think the second method is easier, by all means, go ahead. All right. Okay, I don't have space for part D. I'm going to write part D in below here. All right. Okay, let me see. Part D. I'm going to write part D here. No space. All right. You have y equals to x plus 7 power 5 and x minus 5 power 3. Okay, so this is now my u, this is now my v, dy dx. We copy your u, differentiate your v, bring the power down, copy the bracket, reduce the power by 1, differentiate inside. Yeah, remember to differentiate inside the bracket, although here when you differentiate x is just 1. Then I differentiate u, bring the power down, copy the bracket, reduce the power by 1, differentiate inside, and I copy my v. Okay, so from here I can just put this together, x plus 7 power 5, x minus 5 power 2, this is 5, x plus 7 power 4, x minus 5 power 3. Okay, let's look at a common factor. I have these two. I can take out the smaller one being power 4. Alright, and I also have x minus 5, x minus 5. One is power 2, one is power 3. We take out the smaller one, power 2. Right, so I still have a 3 here. Right, now take note that the power x plus 2 here, power 5 here, I divide by power 4, I'm left with power 1, x plus 7 power 1. Right, and the second one, the power 3 here, I've divided by power 2 over here, I'm left with just 5 and x minus 5 power 1, right? Okay, so now we just expand, not this, the power 5, power 4 and power 2 here, we just leave it, expand the second bracket, 3x plus 21 plus 5x minus 25. So when I put it together, I'll get 8x plus, okay, it's not a plus, it's a minus, minus 4. Oh, notice 8 and 4 can still take out. You can take out 2. I'll just leave it. Take out 4 actually, not 2. 8 and 4, you can factorize 4. Left with x plus 7 power 4, x minus 5 power 2, and 2x minus 1. Phew, this is a very, very long question. So, but we are not even done yet because we still have part E, F, G, and H. Oh, goodness me. So, just let you know, part E, we cannot use product rule. We have to use quotient rule. Yeah, you want to call product rule formula number 7. Quotient rule is formula number 8. Y equals to u over v. So, when you differentiate, you get v u prime minus u v prime over v squared. All right. U is the expression below, v is the expression, u is the expression above, v is the expression below. So these are dy dx. Okay, now remember, square root x means x power half. So we start off with v. So, and I think it's better to write as x power half here. This is my v, u prime. Differentiate 1, I get 0. Differentiate square root x is, there's a negative in front, negative half, x, reduce the power by 1, negative half, minus u, v prime is still the same, half x negative half. Okay, divide by v squared, 1 plus x power half and the bracket square. Okay, the next thing is, I think we can simplify this. We can take a common factor. So my common factor, if you can see it, notice it so happens the same. This number and this number is the same. But I have a negative here, and notice I also have a negative here, right? So I think we can just take out the negative for both. That is, I take out negative half x negative half. This time I think it's easier to just to factorize the negative. I think it's because they're both the same common factor, x power negative half, both are the same, x power negative half. So I take them and leave it out. So there's a x power half here, there's a positive here because I've taken out the negative over here, so it's now positive. Alright, so I better put a positive 1 minus x power half, right? And your denominator is just 1 plus x power half squared. Alright, so for the next step, I'm going to cancel out these two, half and negative half. I'm left with 2, whereas this negative half, I will bring it down. There's a square root. Square root means x power half. I put a root here, yeah, and this is 1 plus root x. You can write x power half though, no problem. But we can still cancel it, and there's still another negative outside, right? I can still cancel 2 and 2, so it's 1 over root x and 1 plus root x squared. Man, this is very long. Okay, so this is just part E. Okay, I'm going to put part F here. This is my u, this is my v. I'm going to write one shot. My v is 4x plus 1 power half, u prime is 1, minus u is x, v prime, bring the power down, copy the bracket, yeah, reduce the power by 1 and differentiate inside. you divide by 4x plus 1. There's a square root, power half, you square it. Okay, now here I think we can cancel these two, left with the 2. Okay, I hope this is not too fast. We're going to take out 4x plus 1 power negative half. Okay, perhaps I'll show you two ways. If you find this method is confusing, I'll show you another way. This will be, when I take out power negative half, this will be power 1. Remember, power half and power negative half, when you take out power negative half, this is power 1, this is just 1, right? So this will be left with 2, but I still have an extra x in front, so it's going to give us 2x, and you divide with 4x plus 1 power 1. Okay, now let me erase this. Okay, so now the next thing is we can take 4x minus 2x, left with 2x, right? And this fellow, when I bring it down, okay, see, yeah, power negative half, there's a power 1 here. When I bring it down, is 1 over x power half plus 1, which is 3 over 2. So, and the 4x minus 2x, I'm left with 2x plus 1. I bring this down, power half plus power 1, power 3 over 2. Okay? Should I show you another way? I think this is not too difficult, right? Another way, okay, I'll show you another way here. Now, another way of thinking is that you can treat this as 1 over, this part here. Okay, let me draw an arrow here. You can treat this as square root 4x plus 1 minus the half and half cancel, 2x, square root 4x plus 1, divide by 4x plus 1. Okay, so from here you just multiply top and bottom with root 4x plus 1, root 4x plus 1. This one may be a bit easier. So when I multiply this, right, I'll get 4x plus 1 minus 2x, right? Now this one will cancel. Yeah, but remember you've got to multiply with both of them. So, and your denominator, if you take power 1, you multiply with power half, you get power 3 over 2. So this will give us 2x plus 1 over 4x plus 1 power 3 over 2. Right? Same result. Okay, I'm out of space, but I think G is quite short. I can show you here. So now for G, right, I will not use UV. Why? Because your numerator is a constant. If your numerator means the number on top is a constant, we can just use the composite function method. Put a negative in front. 1 times 1 is 1. Okay, 1 times 1 is 1. I copy the bracket x squared plus 2x plus 7. I increase the power by 1, 2, and I differentiate inside. Now when you differentiate inside, you have 2x plus 2. Now you can take out the 2 here. You're left with x plus 1, x squared plus 2x plus 7 power 2. Okay, I wonder why they put E and F first, because E and F is so much harder than G and H. Yeah, G and H is so much easier. So I'm just show you the last one, G. Okay, sorry, H, part H. H will be y equals 1 minus 2x cubed over x minus 1. So this is my u, this is my v. dy dx will be v u prime minus 6x squared, right? Okay, minus u 1 minus 2x cubed v prime, which is 1 over v squared. So let us expand. Minus 6x squared times x, 6x cubed. Then you minus a plus 6x squared, then minus 1 plus 2x cubed, divide x minus 1 squared. So we can cancel them. 6x squared minus 1 minus 3, okay, 6 minus 2, minus 6 plus 2, sorry, is 4x3 over x minus 1 squared. Alright, so that is number 11. So long. Let's look at number 12. So again, this one involving composite function. Maybe I write this as x and x squared plus 3 power half first. This is my u, this is my v. So you should get u v prime. Differentiate this, bring the power down, copy the bracket, reduce the power by 1 and differentiate inside bracket. When you differentiate x, you get 1, and you want to copy your v. Okay, again, plenty of method, two different methods, sorry, not plenty, to actually solve this. You can choose to either factorize, that is, I will take out power negative half, right? So you're left with x squared. This one, you're left with power 1, which is x squared plus 3. Yeah, if you're familiar with this, by all means, use this. This is faster. No, I don't know. Do you think it's faster? Yeah, you bring it down. There you go. I will get, oops, this is a bit ugly. The sound of the rain, right? You get this, right? Okay. So now, if you don't want to use this, right, there's another way. I will just write this. I put an arrow here. Method 2. Oops, method 2. You may want to write x squared, put the square root x squared plus 3 and square root x squared plus 3. Remember I said you can multiply top and bottom with this. So you get x squared. Root times root is just the root cancel each other off. Oh, this is also quite easy. Right. And you get the same answer. Okay. So it's up to you which method you want to use. Okay. All right, number 13. Okay, moving on. Number 13. Okay, this one you have to use brain. So now, same thing, dy dx. So this will be using quotient rule, v u prime minus u v prime divide by v squared. All right. So this is 4x squared plus 4 minus 8x squared plus 6x over x squared plus 1 squared. So we can cancel 4 plus 6x minus 4x squared over x squared plus 1 squared. Okay. Now, they say determine the range of values of x such that y and dy dx are positive. So there are two conditions. Number one, your y must be more than 0. Okay. If your y is more than 0, now notice your denominator doesn't affect anything because x squared plus 1 you times over is always more than 0. So it's just the numerator that is more than 0. X is more than 3 over 4. This is your first condition. The second condition is that your dy dx must be more than 0. So 4 plus 6x minus 4x squared more than 0. Now this is where you have to solve quadratic inequality. So for me, I'll just divide by negative 2. So you get 2x squared minus 3x minus 2 less than 0. Remember, whenever you times and divide with negative, the sign has to change. So this will be, oh, this is a bit ugly. Let me just get this to be 2, 1 minus plus. So we sketch a graph. The roots are negative 1 over 2 and 2. So less than 0, the region is in between. Remember, this is your form 4 stuff. So your x between these two. So what I need to do is to combine both inequality, and normally what we can use is we use a number line, negative half, 3 over 4 and 2. Between negative half and 2 we can draw like this. More than 3 over 4 is this. This is your equivalent inequality, so your x must be between 3 over 4 and 2. Okay, I think we got one more to go. Question number 14. That's it, right? Number 14. Yes, this is the last one. All right, and this is rather similar to number 13. So we have to differentiate first. V u prime minus u v prime over v squared. So when you expand, you get x squared plus 5 minus 2x squared plus 4x divide by x squared plus 5 squared. You're finding the range of values of x, right, such that dy dx and y are both negative. Okay, but I need to simplify this first. 5 plus 4x, maybe I just put, okay, never mind, negative x squared, right? So x squared plus 5 squared. Okay, there are two conditions. Your y must be less than 0, so x minus 2 over x squared plus 5. Notice this is always positive. The way to think of it is this. If you have a positive negative number, you divide positive number, you always get negative, right? So that's why it doesn't matter. You can just times it over x minus 2 less than 0, x less than 2. First inequality. Second inequality, your dy dx is negative less than 0, 5 plus 4x minus x squared less than 0. I'll just rearrange it to make it positive more than 0, double bracket, factorize this. So we sketch the graph, -1 and 5. More than 0 is this 2n. So your x is less than -1, more than 5. And we want to combine this on the number line. We have -1, we have 2, we have 5, less than 2, less than -1, more than 5. So where's the region for which they overlap? Here. So you know x is just less than -1. Alright, so that is the end of this formative exercise 2.2. But before we go, just want to let you know that we have a series of learning modules that comes with video lesson. So we find that my teaching explanation is helpful for you and you want to learn more, you want to get more material for self-practice, you can actually find this in our website, right? Or you can go to what they call it, our Facebook, and also Instagram, and also you can call us or WhatsApp us to find out more. All right, so thank you very much. I hope you enjoyed this presentation. I hope to see you in the next video. Thank you.